Hi, everyone, and welcome back to another lab. Troubleshooting network connectivity issues between devices such as PCs and switches, as well as between switches themselves, is a fundamental aspect of network administration. These tasks require a systematic approach to identify and resolve problems effectively to ensure smooth communication and optimal performance across the network. So, on today's session, we are going to do some troubleshooting in the lab that you see on the screen. And when troubleshooting a link between a PC and a switch, network administrators or engineers must first verify physical connections to ensure that cables are securely connected and in a good condition. Then the concentration turns to the configuration of both the PC's network interface card, which another word, the NIC card, and the switch port to ensure that they are correctly configured and compatible. And this happens by examining interface status or error counters and configuration settings and implement necessary adjustment to restore connectivity issues. Similarly, when troubleshooting connectivity issues between switches, administrators or engineers must assess the physical connections between devices and verify proper configurations of trunk links or access ports, etc. etc. For example, trunk links should be configured with matching encapsulation methods in both ends. They need to agree on the native VLANs and all the allowed VLANs to facilitate inter-switch communication effectively. We also can examine spanning tree protocol status and check if the port in question is in the forwarding state, but this is a topic for another time. We will need to check VLAN configurations and interface settings. Following these steps can help us fix the issue in a timely manner and increase efficiency. So, in this lab, we are going to explore common troubleshooting techniques for diagnosing and resolving connectivity issues between PCs and switches, as well as between interconnected switches. And we are going to do that by practicing hands on exercises and analyzing real world scenarios where we will develop the skills to troubleshoot network connectivity problems efficiently within a LAN. This will ensure the smooth operation of our network infrastructure. So, with this being said, I will do the usual where I go over the lab objective and then go through the topology and then the switch VLAN table and then go through the lab task and finally walk you through the lab solution. So, first things first, the objective of this lab is to develop proficiency in troubleshooting network connectivity issues between a PC and a switch, as well as between interconnected switches. So, we are covering how to troubleshoot a LAN from a basic level point of view. And we are going to do this by applying a systematic troubleshooting techniques so participants will learn to identify and resolve common problems affecting network communications, including issues related to physical connectivity, or interface configurations and switch settings. So, regarding the lab topology, as you can see on the screen, it is very simple. It consists of two networks. We have network that has VLAN 100 and the other network is VLAN 200. So, we see here on the screen PC1 is connected to Switch1. PC1 is part of VLAN 100. However, PC2 is part of VLAN 200 and is connected to Switch1. We then have switch 1 connected to switch 2 via gig Ethernet 01. And then on the other side, we have PC3, which is part of VLAN 100. And we have PC4, that is part of VLAN 200. And both PCs are connected to switch 2. Regarding the switch VLAN table, we have the device name, the interface ID, and the interface mode, and the allowed VLANs. So we have a couple of devices in our table, and we have three interfaces per switch. So the first interface, gig Ethernet 01, which connects to switch 2. It operates as a trunk, and the allowed VLANs are 100 and 200 VLANs. We have interface fast Ethernet 01 is going to operate in access mode and is going to be part of VLAN 100. Whereas fast Ethernet 02, it also is going to operate as an access mode and is going to be part of VLAN 200. On the other hand, we have Switch 2 and we have Gig Ethernet 01, which is going to operate as a trunk mode and is going to allow VLAN 100 as well as 200. Again, fast Ethernet 01, that is going to operate as an access mode and is going to be part of VLAN 100. And finally, we have fast Ethernet 02, and that is going to also operate as an access mode and is going to be part of VLAN 200. If I scroll a little bit down, we can find the host IPv4 addresses. PC1 is going to have 192.168.100.1, and that is going to be part of VLAN 100. PC2 is going to be part of the 192.168.200.1 network and is going to be part of the VLAN 200. And then we have PC3 that is going to have this IP address 192.168.100.2 and is going to be part of VLAN 100. And finally, we have PC4, which is going to have 192.168.200.2 IPv4 address and is going to be part of VLAN 200. So next, I'm going to talk about the lab task. And as you can see on the screen, we have 6 different tasks. And the first task is to investigate as to why the link between PC1 and Switch1 is down. And we are going to try to troubleshoot the issue and fix the problem accordingly. Then we move to step number 2, where we are going to troubleshoot the link between PC4 and Switch2 and do the same thing, fix the problem accordingly. And then once we have completed step 1 and step 2, what we are going to do next, we are going to initiate a ping from PC1 to PC3, and we are going to check if the ping is successful, and then we will do further troubleshooting accordingly. We move to step number 4, where we are going to do some troubleshooting and investigate why PC1 is unable to ping PC3, and similarly with PC2 is unable to ping PC4. And we are going to find the problem and we are going to fix it. And we are going to do that systematically. Once we have completed step 4, we are then going to move to step 5, where we are going to retest the ping between PC1 and PC3 and also ping between PC2 and PC4. Now, if the ping is successful, great. If it's not, we're going to keep further troubleshoot the problem until we actually get to the bottom of the network connectivity issues between the VLAN 100 network and the VLAN 200 network. Now, once we make sure that both VLANs can communicate with each other from each side of the network, we can then go ahead and save the configuration, and that will be the last task, as you can see on the screen. Okay, now that we are ready to go ahead and jump into the lab solution, it is your chance to pause the video and give it a go yourself. Try to resolve the issue on this lab by yourself, and if you read the video description, you'll see that I included the lab objective and the lab task, as well as the tables that you see on the screen. I also created a lab document for you to download so that you can challenge yourself by building the lab and go through the list of tasks on your own and whenever you want to. I also have included the lab setup ready to go for you to troubleshoot, and you will see that I included a couple of labs. The first one is pre-troubleshooting and the second one is post-troubleshooting, so that you can compare your configuration with mine. So again, pause the video now or just keep watching. So let's tackle the first task, which is to investigate why the link between PC1 and Switch1 is down and fix this accordingly. And by the way, we can see from the network topology on the screen that there is a problem between PC1 and Switch1. But in real life, you would not have this leisure, and that you will have to follow a systematic approach to solve the issue as soon as possible. So one of the methods that you can follow is to use OSI model layer approach when you do troubleshooting. For instance, we start with the physical layer. We check the all ends are compatible and no hardware issues, etc., etc. And then go to the data link layer where we check the logical connection between network devices. And then we can move into the network layer where we check the logical addressing and routing, as well as packet forwarding, so on and so forth. So in real world scenario, you would check the physical connection to ensure that the Ethernet cable is securely connected to both of the PC's network interface card and the switch port interface, and check for any physical damage to the cable or the connector pins. You also need to verify the link status on the switch port and the PC's network interface, where you can look for the LED indicators on both devices to confirm link connectivity. For example, a solid or blinking LED or LED usually indicates an active link, etc., etc. Then you check the configuration is correct on the network interface card and the switch, and you check the misconfigurations or conflicts with other devices on the network, and the port on the switch is configured appropriately. And you can check things like the VLAN membership, the speed of the interface, the duplex settings, and any security features such as security or VLAN access control lists, but more in that at a later stage. You can test the hardware, as at some point the hardware will wear out and a problem with hardware is inevitable. So you might need to raise attack case if you are using Cisco kit, etc., etc. You can also do some ping testing and perform some packet capture. And finally, if you are still unable to resolve the issue, then escalate to higher level support personnel or consult vendor documentation for further assistance. Okay, with that being said, what I'm going to do next, I'm going to tackle the first step of the lab task, where we are going to investigate the problem that is being caused from PC1 and Switch1. As you can see on the screen, you can see that the link is down and there is a physical connectivity issue. And what I'm going to do, I'm going to log into the Switch CLI first. And then the first thing that I'm going to check is I'm going to issue a command called show IP interface brief. So what I will do, I will go to enable mode, and then from there I will issue show IP interface brief. And if I maximize this, we can see that fast Ethernet 01 is in the down state. And then what I'm going to do next, I'm going to issue this command, which is show interface status. If we were then to look at the output from the show interface status, we can see that fast Ethernet 01 is not connected at the moment. And it is part of VLAN 100, and the duplex settings is set to auto. So we need to find out what exactly the setting that is operating at, whether in full duplex or half duplex, and we can find that out from the next command that I'm going to show you shortly. And then we can also learn that the current speed that is being set on the interface is 10 megabits per second. And in here, we get the type of the physical interface. We have 10/100, and that refers to the interface's capability to operate at either 10 megabits per second or 100 megabits per second. And the base TX specifies the type of Ethernet connection using twisted pair cables. Specifically, base TX indicates that the interface supports Ethernet over twisted pair cables, commonly using RJ45 connectors. So what I'm going to do next, I'm going to say show interface fast Ethernet 01. And as you can see, the first line indicates that the physical layer is down and the layer 2 is down as well, and it is disabled. And what we can learn is that the duplex settings currently is set to half duplex, and the current speed is 10 megabits per second. At the moment, we can see that there are no drops. So what you see here, input queue, we have the 0. This is the current number of packets in the input queue. We see 75. This is the maximum number of packets that can be held in the input queue. We have 0 that indicates the number of packets have been dropped due to the input queue being full. And then finally, we have the last 0, which is the number of times that the input queue has been flushed. And here we see the total output drops, which indicates that the total number of output drops that occurs when the output queue is full. If we then examine this line, we can see that we get no input errors, CRC, etc., which indicates that the cable might not be damaged. Now, the final check that I want to do on Switch 1 regarding the connectivity problem between PC1 and Switch 1 is revealing the current configurations for interface fast Ethernet 01. So what I will do, I will say show run, and then here you can see the current configuration for fast Ethernet 01. So currently the interface fast Ethernet 01 is part of VLAN 100, which is correct, and is operating as an access mode, which is also correct. And the current speed is 10 megabits per second. So with that being said, we can then jump into PC1. And then if we go to config, and then under the interface section, you will find the network interface card, which is fast Ethernet 0. We click on that one, and that will reveal the fast Ethernet configurations, as you can see on the screen. And you can see that the current bandwidth is set to 100 megabits per second. And we have learned on the switch that the current bandwidth is set to 10 megabits per second. Because of that mismatch speed, that will cause a problem. We also can see that the duplex settings is being set to half duplex. That matches with what we've seen under the physical interface on Switch 1. Okay, in order for us to actually fix the problem, what we need to do, we need to go back to the switch, and we go to config mode, and we go to the interface fast Ethernet 01. And under this level of configuration, we can say no speed 10, and we're going to say speed 100. And we're also going to set the duplex into full. But before I do that, we would need to do the same on the actual PC. So I'm going to set that to full. And here I'm going to set that to full as well. Now you can see that the interface is up. And if I say end, and if I go and say show IP interface brief, you can see that fast Ethernet 01 is in the up state, which means layer 1 is operational and layer 2 is also operational. So next, we are going to move into task number 2, where we are going to troubleshoot the link between PC4 and Switch 2. And we are basically going to repeat exactly the same process as what we have discussed. So what I'm going to do, I'm going to log into Switch 2 CLI. And the first thing that I'm going to do, I'm going to go to enable mode. And from here, I'll say show IP interface brief. And you can see that we have similar problem with fast Ethernet 02. So this confirms that layer 1 and layer 2 are not operational. And then what I'm going to do, I'm going to say show interface status. And if we were to look at fast Ethernet 02, we can see that it says now is not connected, is part of VLAN 200, and the current duplex settings is set to half, and the speed is set to auto. So what I'm going to do next, I'm going to look at the fast Ethernet 02 physical interface statistics, and to do that, I will say show interface fast Ethernet 0/2. And again, you can read that the fast Ethernet 0 is in the down state and is being disabled. We learn that the current duplex settings is set to half and the current speed is 100 megabits per second. Again, you read the counters because that can also indicate a problem with the actual physical cable. And you can see from the counters here, we have no CRC issues or input errors or any drops. So what I'm going to do next, I'm going to actually reveal the current configuration for fast Ethernet 02 by saying show run. And in here, we can see that the fast Ethernet 02 is part of VLAN 200, which is correct. And the switch port is operating as an access mode, which is also correct. We can see that the duplex settings is set to half, which is not correct. If we then go to PC4 and repeat the same steps, we go to config and then interface section and then fast Ethernet 0. You can see that the current bandwidth is set to 100 and the duplex settings is set to full. So we would need to mimic the same configurations on the switch, and we are going to say config terminal, and then we're going to say interface fast Ethernet 0/2. And in here, we are going to issue no duplex half. And we are going to say duplex full. As you can see, the interface is went up. So what I'm going to do next, I'm going to issue the show IP interface brief. And you can see that the fast Ethernet 02 is in the up state. Next, we are going to tackle step number 3, where we are going to ping from PC1 to PC3 and PC2 to PC4. So I'm going to go to the CLI, and in here I'm going to say ping 192.168.100.2. And as you can see, the ping has failed. Now I will do the same test with PC2. So I'm going to say ping 192.168.200.2. And again, the ping has failed. And that leads us to move to step number 4, where we are going to do some troubleshooting and investigate why PC1 is unable to ping PC3 and PC2 is unable to ping PC4. So in order for us to solve step number 4, we would need to do further troubleshooting between Switch1 and Switch2. And we are going to do that systematically, where we are going to check the VLAN settings. We are going to look at the trunk mode, and we are also going to look at the VLANs that are allowed via the trunk. We can also look at the interface between Switch1 and Switch2. We can check STP type and check if the port is in the forwarding state, but this step is not applicable for this lab. And we can look also for syslog messages to look for hardware or software issues and try to isolate where the problem might be. So what I'm going to do, I'm going to go back to Switch1. So we have Switch1 on the left-hand side and Switch2 on the right-hand side. And the first check that I would do is, first of all, we need to check if the VLAN actually exists on both switches. So on Switch1, I'm going to say show VLAN brief and repeat the same command on Switch2. I will maximize the window, and here we can see that fast Ethernet 01 actually lives in the right VLAN, which is VLAN 100, and fast Ethernet 02 is part of VLAN 200, which is also the correct VLAN. Let's do the same thing on switch 2. We can see that fast Ethernet 01 actually lives in VLAN 10, and I can't see any VLAN that is 100. And the second VLAN is 200, which is correct, and fast Ethernet 02 is part of the right VLAN as well. So we spotted one problem with fast Ethernet 01, which is part of VLAN 10, and it should be part of VLAN 100. So that's the first problem that we would need to tackle. So I'm going to go to configuration terminal, and I would say interface fast Ethernet 01. And from here, I can say no switch port VLAN access VLAN 10. And I can either create the VLAN from the global configuration mode, or I can actually create it whilst I'm actually associating the interface with the respective VLAN. You will see what I mean. And if I issue switch port access VLAN 100, bear in mind that I haven't created VLAN 100, but it will be created automatically by issuing this command. It will say access VLAN does not exist, creating VLAN 100. So VLAN 100 is already been created as soon as I hit that command. So I will end this, and then I'll go back to my show VLAN brief command. And this time you can see that fast Ethernet 01 is part of the correct VLAN, which is the first step of troubleshooting the problem. Next, what we need to do is we need to look at the trunk configurations between switch 1 and switch 2. So you can say show interface status, and I'll do the same thing on switch 2, show interface status. Maximize the screen again. And in here, if we were to look at Gig Ethernet 01, you can see that Gig Ethernet 01 is connected, but is part of VLAN 1, which is the native VLAN. That means is operating as an access mode, which is not correct. If we do the same test with switch 2, you can see that Gig Ethernet 01 is connected, however, is operating as a trunk mode. So we would need to fix this issue on switch 1. So I'll go to config terminal, and from here I would go to interface Gig Ethernet 0/1, and I would say switch port, actually I would say no switch port VLAN, access VLAN 1, and I would say switch port mode trunk, and you can see that the link has come up. And if I issue the same command again, you can see this time that Gig Ethernet 01 is operating in trunk mode. So now that we have fixed our topology, and if I go back to my topology, you'll see what I mean. You can see that everything turned into green. Let's test again connectivity between PC1 and PC3 and PC2 to PC4. So I'll go back to my CLI and up arrow to get the previous command and hit enter, and you can see that I'm able to actually ping PC3 successfully. Let's do the same command on PC2. You can see that the ping has failed, and there must be another problem with the configurations between Switch 1 and Switch 2. And what I haven't checked with you is the allowed VLANs for the trunk in question. So I'm going to go back to Switch 1 and check the trunk configurations. And you can say that by saying show interface trunk. If we look at the output from the show interface trunk, we can see that the encapsulation method is using .1q and the native VLAN is 1. And you can see that the VLANs that are allowed under that trunk is from 1 all the way to 1500. And currently the allowed and active VLANs are 1, 100, and 200. Now let's do the same test on Switch 2. Straight away, you can see that the VLANs that are allowed on the trunk is only 100. So 200 is being denied. And that's why PC2 is unable to ping PC4. So what I would do, I'm going to go to config terminal and I'm going to say interface gig ethernet 0/1. And I'm going to say switch port trunk allowed VLAN. And this is very important at this step because if I then say allowed VLAN 200, that will override the existing VLANs. And you will, if you do that in a production environment, you are going to bring your network down. So be very careful with this command. And what you need to do, you can add another VLAN by saying the add command. And if I just remove this word and try to question mark this to get the content sensitive help, you can see all the options that you can actually have to perform this command sensibly. So I'm going to say switch port trunk allowed VLAN add 200. And then I'm going to say end. And I'm going to repeat the same command, show interface trunk. And this time you can see that VLAN 100 and 200 are part of the trunk gig ethernet 01. So now let's go back to PC2 and initiate that ping again. And you can see that the ping this time was successful. So at this point, we can then go ahead and save our configurations. So I'll just say WR on switch 1 and do the same thing on switch 2. And that's it, folks, for this video. If you found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn on notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.